Professor David Mindell is a professor of aeronautics at MIT and also divisional professor of the history of engineering and manufacture. He co-chaired the task force on work of the future at MIT. Let me end this. Sorry. It's Professor Mindell is a really rare combination with both the engineering background and the humanities background, which I really respect as the precisely what we needed to understand and solve today's mobility problem cross scale and cross mode. He researched on a variety of relationships between people and machine, and he has developed and commercially licensed the spread spectrum sonar technology for undersea navigation. He wrote 6 books, including the most recent one on the work of the future that hopefully Professor Mindell will touch a little bit, as well as the book like Our Robots, Ourselves, Robotics, and the Myth of Autonomy. He's the co-founder and CEO of Humantix Corporation, which is pioneering the micro-location technology to revolutionize how people and machine locate, navigate, and collaborate. I just see, and one more word is, Dave is also a like key supporter and advisor to the mobility initiative and contribute to the initial concept and as well as many of the implementation of the mobility initiative. So I really thank David for joining us today. Last year, I invited him to talk about the micro-location transit, and today I will invite David to talk about the regional air mobility. David, the forum is yours.
Thank you. It's great to be back here, and thanks to Jinha for giving me a whole week to prepare this talk. We had lunch the other day and he said, how about you give the talk on February 18th? And this is not a canned talk. I've never given it before. So it's a lot of new thoughts, but it's of course exciting and interesting to bring something together for the first time. My goals today, let me get my screen share up here. My goals are to introduce the idea of regional air mobility and some of the key players and issues. And it's really, think about it as an introduction, and also to show how it links to some national priorities in the United States right now, such as the work of the future and manufacturing and R&D. And also just to encourage the mobility initiative to think in the third dimension. There's a lot of exciting talks here. And I'm excited for really every single one for the rest of the semester, but nearly all of them are either automotive or surface-based. And I just want to remind everyone by this talk at some level that there are other modes of transport that should be considered, and aviation and aerial mobility is really one of them. And of course, important how it links to the other modes of transportation. So let's not assume that mobility means automobiles. I also am beginning a series of conversations, which will probably end up in a book, about the future of industry. And how do we think about a future of industry in a way that's optimistic and embraces technology, but is also primarily human-centered, not utopian, and looking forward to an equitable and decarbonized future. And that's not actually an easy problem, given the way that we've become used to talking about technology. So you may well have heard of a lot of excitement about UAM, urban aerial mobility. This is just one of many slides from NASA. There was about $7 billion in investment put into this industry last year. There were 5 SPAC IPOs, Blade, Joby, Archer, Vertical. There's another one this year by Eve. And according to a McKinsey study, there were options and orders and letters of intent for about 7,000 aircraft worth almost $30 billion just in 2021. And that outpaces the order volume for conventional aircraft by a factor of 10. Slightly skewed comparison because 2021 was a particularly bad year for commercial aircraft orders, but still lots of enthusiasm, lots of excitement for novel kinds of aircraft that will whisk you away. And in fact, one of the players is even called Whisk, from urban vertiport over the traffic to your home in the suburbs or somewhere else. You, I'm sure, have heard some of the names here. Joby, who's partnered with Uber and Toyota and acquired the entire Uber Elevate operation. Archer has an order from United Airlines, Vertical Aviation, Blade Aviation, Lilium, really interesting space. Also worth pointing out that almost all of the stock prices of these companies are down in the 60 to 70% range since they went public. That may well say more about SPACs than the prospects for urban air mobility. And if you're a believer in it, it's a good time to buy stocks probably, but it reflects a certain amount of market uncertainty. And I understand that uncertainty because UAM really depends on about, I count sort of 7 different revolutions: new airframes, new energy storage, new controls and autonomy, new propulsion and electric motors, new business models, new infrastructure around vertiports, new regulatory regimes, new airspace design, and new air traffic control. And those last 3 are all under the control of the FAA, who's not known for moving quickly and still smarting from the 737 MAX disasters, and I think they're probably not too great at distinguishing the organizational failures there from the technology failures. I'm not going to say more about UAM today, but I am going to talk about a slightly different way to think about this problem, and that's regional air mobility as opposed to urban air mobility. There's a really great report that was done last year by a group at NASA. And actually, Kevin Ancliffe, who led that team, I think is on the call today, as is Maxime Gariel from X-Wing, and there were folks from NASA and Boeing, Reliable Robotics, Magnix, Ampere. And this one quote sort of captures the sense of regional air mobility, focusing on building on existing airport infrastructure to transport people and goods with innovative aircraft over with improved affordability and efficiency over existing options. And multiple technologies do not need to advance simultaneously for RAM to advance. So I think as the authors of this report, and many of the things I'll share in the next few minutes come from this report, it feels like a much more here today type of model. I would highlight also in this quote the notion of community compatible, so low noise, low nuisance, low carbon emissions, transportation mobility technologies to benefit ordinary people. So think about modern aircraft, high utilization enabled by new business and operating models, kind of ride sharing models. And I'll talk later about autonomy and electrification for both logistics, packages, e-commerce. One startup is focusing on organ delivery, and a new passenger experience, including not only how you book transportation multimodally, but also how it's integrated into other transportation modalities. And I think the key starting idea, and really one of the drivers, and this is why having trouble advancing my slide here, a second. When I shared my screen, my mouse disappeared and my keyboard is not. There we are. The key idea is existing airport infrastructure. So you today can buy in the United States a commercial ticket to one of 500 airports in the United States. But that is less than 10% of the commercial airports in the United States. This image is a typical aviation chart of New England. And you can see Boston here and Cape Cod, and you can fly commercially from about 6 of these airports: Hyannis, Nantucket, Martha's Vineyard, Providence, Worcester, and Boston. But there's another 24 airports just in our little southeast corner of New England. Yet 0.6% of US airports support about 70% of domestic travel. So at some level, all we're talking about is making use of infrastructure that we already have that is largely supported by US taxpayers. There's a long history here. The 1946 Federal Airport Act created these 5,000 airports. There were many returning pilots from World War II, a huge increase in the number of trained pilots, many training fields, and the vision was, as way back then, as akin to the early interstate highway system. One of the things that happened was that when jet travel was introduced in the late 50s and matured in the 60s, jets tended to concentrate on larger runways. And, Karl Marx famously said, the hand mill gives you society with the feudal lord, the steam mill gives you society with the industrial capitalist. That's actually not true, because the social relations don't flow necessarily from the technology, but I can parody that by saying the fossil fuel jet engine gives you the hub and spoke system that we all suffer in the airlines today. So one question for regional air mobility is just simply, how will electrification, sustainable fuels, and various forms of autonomy enable change in that system? It's not a technology determinist story, but the technology does open up certain choices for us as researchers, industry, investors, policymakers, that we can choose to take advantage of these systems. There's also parallels in the sort of early 2000s that NASA had a great program called Small Aircraft Transportation System, created these innovative aircraft called very light jets, and there was even concern that the very light jets would darken the skies. That didn't quite happen. This is a Wikipedia page under very light jet, and of the 24 or so projects they list here, only the green ones on the top, there's 4, are actually in production today. It's from Cirrus, Honda, Cessna, and Embraer. They're all good airplanes, but they kind of provide the lower end of the private jet scale. They didn't revolutionize too much. Although a lot of that thinking really does carry forward in today's RAM story. Jim Womack, our friend, who's often, I don't know if he's here today, but has written a lot about lean. And even in this era, Jim was writing about lean transportation options. A lot of his ideas and that writing still really holds up quite well today from RAM. RAM is lean air transportation. It's flexible specialization, it's mass customization, as opposed to the 20th century mass production model that the airlines have given us. And there are many other examples in the past and current day. If you've ever been to Alaska, you'll know that Alaska, pictured here on the left, the red are the many, many public use airports in Alaska, thrives on small aircraft transportation. Over on the right is the route map from Cape Air, still fairly hub and spoke looking, but they serve the Northeast and are largely subsidized by the Essential Air Services program out of the federal government. And unsurprisingly and appropriately, they've placed a major early order from Eviation for an electric aircraft to cover some of these routes. And in the middle, my friend Nat Sims is on today, who's a pioneer in medical devices and also very thoughtful about air transport coming out of northern Vermont. He sent me this schedule from Air Vermont from 1983. So when we talk about regional air mobility, at some level, we're just talking about things that we already have or are already working in some places, scaled in a new way with new technology. Here's a typical trip that I take. I have a small Beechcraft Bonanza. It was designed in 1947 and still manufactured today. And this trip from Hanscom here in Lexington to northern Vermont takes about 35 minutes as opposed to 3 hours driving. It's about double the fuel, so it's not particularly green, but it's very convenient. And once you're in Vermont, you still have access to the entire Northeast from an air mobility point of view. So general aviation pilots have been doing this for a long time. And let's be clear, we have a system like this today. We have a complete private elite air transportation system based on this publicly funded infrastructure in the form of private jet air travel and other types of aircraft. The public image of it is pampered people with sunglasses, and some of that is certainly true. But most of it is supported by business, and business supports these aircraft because they pay, and there is value to mobility at this higher level. And partly, again, the vision for regional air mobility is to democratize access to this system and make this type of mobility greener and less expensive and accessible to more people. So looking at car trips, this is an image from industry. If you're traveling in an urban setting, you have many options. And we, of course, know that with this group: bicycles, rideshare, trains, buses. But when you're in the medium range, say 50 to 500 miles, it's almost only car trips. There are 3.5 billion car trips in this range area every year in the United States, over 1 trillion passenger miles. And I don't think anyone expects aviation to take over all of those trips, but even a small fraction is a viable industry that can also really make a difference. On the cargo side, if I send a package from Boston to Rochester, New York, where I happen to be from, that package will go through St. Louis or Memphis on its way. It'll go on probably 3 aircraft, 2 trucks, 6 hands-off, over 1,000 miles, and significant carbon emissions associated with that. And of course, the world of e-commerce and kind of atomized distribution is very amenable to thinking about some of these models. Many e-commerce providers would like to provide you a green option for green delivery from their warehouses. The technology for that really doesn't exist today. So a few of the players, and there's many players here, but I'll pick a couple of them. On the top left is the Eviation Alice, a company, really interesting company doing electric aircraft. I mentioned them as ordered by Cape Air. They're in the Pacific Northwest. On the right is from Electro.Aero, a blown wing hybrid electric aircraft. Electro.Aero is founded by MIT graduate John Langford, who had started Aurora Flight Sciences, and many of my colleagues, Mark Drela and John Hansman from AeroAstro, are involved with them. They're based out of Virginia. The bottom left is really cool company. So the aircraft is called Alia. It's a mixed eVTOL from a company called Beta in Burlington, Vermont. And they've been progressing at an amazing pace lately. They're the ones I mentioned who are starting with organ delivery as their model. They're also building VTOL and charging infrastructure. Really interesting and exciting to see such a innovative company in Burlington, Vermont, which is not a place usually associated with innovations in aerospace. And again, part of the value of regional air is we can begin to stimulate some of those areas. And the bottom right from X-Wing, I think Maxime Gariel, the CTO, is on today. X-Wing was founded by him and Mark Petit, from both of them MIT graduates. They're located in Northern California, and they're focusing on autonomy for regional cargo delivery. This is the Cessna 208 Caravan. It was actually designed by FedEx with Cessna, and covers many of the feeder routes that bring packages to the larger hubs. As you can see, none of these 4 companies, and this is only 4 of maybe a dozen, are actually approaching the problem in the same way. And I think that's exciting. There's a lot of different thinking about it. There's no monolithic model. It hasn't really converged yet in that way, but there's a lot of great innovative work going on. Another one of those companies is Lilium, also has gotten a lot of attention. But just picture this as one form of the vision. Lilium builds this electric kind of, well, they will build an electric 7-seat jet. On the left is a route map that they've proposed for Northern California. On the bottom right is an image from the NASA RAM report that I mentioned earlier about the just the number of airports in this country. And what does a world look like where we can affordably fly with a low carbon footprint to or from many of these airports with an on-demand model? I think there's two real key enabling technologies here. One of them is electrification. Um, Electric motors are very efficient compared to fossil fuel motors, and obviously they have reduced emissions, reduced noise, reduced maintenance, ultimately reduced cost, although there are real challenges associated with the energy density of batteries. I put these two images up here just to show that Airbus is working heavily on this technology, as is Rolls-Royce and a number of the other big players. This image on the right shows you a great image of an electric powertrain for an aircraft that broke the world speed record last fall for an electric aircraft. You can see the batteries, a kind of black unit up in the nose with the power converter and thermal control. The actual motor is only the little silver cylinder behind the propeller. But batteries are 40 to 60 times less power dense than jet fuel. And we're not going to see airliners the way we think of them powered by batteries, I think, any time in my professional lifetime, even with nice generous assumptions of 8% improvement for the year. So electric aircraft will be regional for the foreseeable future. And regional air mobility provides a wonderful place for electric aircraft to mature. There's also, and some of this is mentioned in the NASA report, some side benefits to electric aircraft in a regional setting. As sites for electric power consumption, airports can drive new investment decisions about generation and distribution and charging. Many airports are already reconceptualizing themselves as sites for solar farms. They tend to be public use areas with lots of open space that aren't usable for other things. There are 146 airports in the country with renewable energy projects going. The largest is at Indianapolis International Airport, which produces more than 30 million kilowatt hours per year. Second key enabling technology is autonomy. And for autonomy, you don't necessarily need to think only an aircraft that flies by itself. I do think that an imaginable end game in 3 to 5 years is an electric aircraft where you push a button and it will move safely from one place to another. But there are a lot of steps along that way, including reduced crew from 2 to 1 pilots, simplified vehicle operations, which enable reduced cost for certifications and duty days. And many of these options afford improvements in schedule flexibility and routing, where you don't have to return a pilot home every night, or you're not limited by a 6 or 10-hour duty day. Obviously, the aviation, the autonomy problem is aided somewhat by the automotive industry and all the work going in there, although autonomy is proven in aircraft now for decades in the military realm and elsewhere. And many of the major technical problems have been solved, and now we're facing certification problems. The FAA hasn't quite figured out how to handle it right, except for, I will point out, and I put this up, Garmin Emergency Autoland. This is a technology that is certified, that you can buy today. It won the Collier Trophy last year. It's the highest award for aviation innovation. And in a couple of aircraft, including the Cirrus jet up on the upper right, if the pilot is incapacitated, a passenger or the pilot can push one button, the aircraft will declare an emergency. It will find the nearest suitable airport, plan a landing and land automatically. So that's an emergency certification. A lot of the rules are easier for emergencies, but it is a kind of foot in the door, camel's nose under the tent for autonomy in more normal operations. So to close, I want to talk about beyond the technology, which of course at MIT we can talk about all day, but let's think about how RAM fits into larger priorities. I'm a big fan of Lewis Mumford, who was one of the founding thinkers in the field of the history of technology, and Mumford was a regionalist. In his classic book in 1934, very much inspired by early aviation, He says, just as every region has a potential balance of animal life and vegetation, it has a potential social balance between industry and agriculture, between cities and farms, between built-up spaces and open spaces. Bill Cronin's book, I put it up here as well, Nature's Metropolis, does a beautiful job of explaining the interdependent relationships between cities and countries. And there's a strong current of regional thinking in technology and obviously in urban studies and planning. City and country need each other. The United States right now will benefit by building closer social and economic ties between rural and urban areas. And as I mentioned in my work on the subway system when I gave a talk here a year and a half ago, getting people from lower income, lower cost of living areas into higher income, higher paying areas and getting them home again where they can live affordably is a valuable goal for much of our technology and business. And I should hasten to add that I don't think that all of the value of regional air mobility has to do with city to country or urban to rural transit. I think regional to regional, intra-regional is quite important as well. Jinhua mentioned the book that David Autor and Liz Reynolds and I just published based on the work of many people at MIT on the work of the future. And of course, remote work is now a thing. I don't need to go too far into this because I'm sure you're all familiar with it, but to revitalize work in this country, we need to revitalize the US industrial base, very heavily regionally oriented. We want to share prosperity beyond the coastal cities, and labor markets tend to be very regionally focused. And finally, and I put this slide here, Jinhua pointed me to the work of his colleague, Jose Barrero. I think the website is WFH.com, where they have an amazing amount of survey data and valuable tracking data and thinking about what remote work will look like. I work with a chip designer at my company who lives in northern Vermont on a farm with his family. Rural broadband is an issue that is actually kind of the flip side issue of rural mobility. But once we got him broadband up there, he's able to design chips and then come down to our office in Waltham maybe 3 or 4 days a month when we need hands-on work. That's a sustainable, supportable work lifestyle for him. And I think many others have been rethinking their mix of urban and regional presence enabled by different ways of working in the office. One of the other recommendations from our Work of the Future project, built on the work of other MIT colleagues of our, Simon Johnson and Jonathan Gruber, their book from a couple of years ago, before the pandemic, but it's still remarkably resonant, about Jumpstarting America, about how US investment in R&D has, first of all, it's declined. That's been a problem. But it's also exacerbated a growing regional imbalance. We can all think of the successful innovation hubs in Boston and Austin and Seattle and Silicon Valley. But Gruber and Johnson really articulate ways to think about bringing similar dynamics and similar positive feedback loops to more regionally based cities. And they actually have a great website based on the book where you can go look at their data and run different scenarios on it. And number one in their suggested potential innovation hubs happens to be Rochester, New York, where, as I mentioned, I grew up. So I went and I looked up Rochester, New York's air connections, and the only place that you can get to are these hub and spoke: Boston, New York, Detroit, Philly, Chicago. You can't go from Rochester, New York to Columbus, Ohio. You can't fly from Rochester, New York to Burlington, Vermont without a connection. And as we think about revitalizing manufacturing in this country, Suzanne Berger's work has shown us that one of the great problems with small and medium-sized manufacturers has been they're not beautifully well connected into their own regional networks. There are a number of ways to solve this, but moving people and moving goods conveniently and quickly at regional scales should certainly be one of them. And then you add to that, of course, revitalizing the aerospace supply chain. Who's going to make all the pieces and the composite parts for all of these exciting new startups? And there's just a tremendous amount of opportunity for the aviation infrastructure in this country to contribute to the revitalization of US industry. So I'll close there and open it up for conversation, really by saying, I think the vision for regional air mobility is still gelling. As I mentioned, there's a lot of different players doing a lot of exciting different things, but the pieces are increasingly there, and a concerted push can really tie it together and push it through. Questions remain about the path for electrification, how quickly these new vehicles can get certified and up to speed, how do we maintain the safety that we expect from both air and surface communication. You may have noticed the FAA administrator resigned yesterday. I think it's really important they find a new administrator who understands autonomy and safety and these new technologies, although I'm not too hopeful about that. And it's just a really exciting moment where technology is changing very rapidly. How we work and how we manufacture and how we move things around is changing really quickly. And there's just a lot of opportunity for thinking, again, about the future of industry in ways that are innovative, human first, decarbonizing, but not utopian and pragmatic. So let's return our eyes to the ground and get to work.
Great, thank you so much, Professor David Mindell. So I'll start with, given that you mentioned that Kevin Antcliffe is one of the authors of the report, I may actually invite Kevin to give a short remarks to respond to David's presentation. Kevin.
Sure. I almost gave a standing ovation there. I think David did an excellent job in providing an overview of regional air mobility. I think it's an excellent opportunity, really great questions in the chat. Looking forward to getting into that conversation. But yeah, I think one of the things that I really focus in on and that David mentioned is, one of the most powerful aspects of this overall vision is that multiple technologies don't have to mature simultaneously for it to happen. It's already happening. Yes, it's for the elite. It's for the pampered people with sunglasses, as David mentioned, right? But it's starting to integrate these different technologies that have evolved over the years and integrate them to reduce the cost and make it available for more people. And I think one of the staggering statistics that David also mentioned is, 0.6% of US airports, the top 30 largest airports in the United States, out of those 5,050, support 70% of the domestic air travel. So this is a major problem that we're all aggregating into 150, 160, 170 passenger and not actually going where we want to go. One of my favorite quotes, and I'll stop with this because I'm really passionate about this and can talk for days. But essentially, air travel today is really good at getting you from where you don't want to be to where you don't want to go. And we're really trying to change that to be more flexible to where we actually want to travel. Thanks for the opportunity.
Great, thank you, Kevin. So David, I really like that you highlight the distinction between the UAM versus RAM, right? That's the first time I see this is such a clear framework to really distinguish between them. You mentioned on a little bit on the UAM side first. You said for the UAM to succeed, it requires 7 revolutions in technology policy sector, right? First of all, if you can recap the 7 would be great. For many audience, you spoke very quickly, so many may cap all day. But then also I want to see your remarks on that. So for industry to succeed, requires a 7 revolution. That's from one side exciting as a scientist research, but on the other side is precarious as a business, right? So can you hinge on the investment on the 7 revolution we have? And then lastly, I would add to that, compared to the UAM, the RAM you said is much more today, right? It's much more feasible. So in terms of the 7 requirement, if you have a comparison between the RAM and the UAM, which are common challenges, which are distinct RAM versus UAM?
Yeah, this being MIT, Zhenhua, you probably know how to count, and I probably mentioned more than 7. And it's a little bit artificial only because some of them are kind of overlap into each other. You know, the UAM aircraft are radically new kinds of aircraft that we don't have a lot of experience with, so new airframes. The electrification, which is both new energy storage and new propulsion, that's obviously shared with electric RAM. New controls in terms of autonomy also shared with electric RAM, although not all the UAM players are focusing on autonomy. The new business model of the kind of aerial rideshare, which is not something we have a whole lot of precedent for, although we have some in the sense of helicopters and urban, sort of urban to airport travel. A key one, I think, is the new infrastructure, vertiports, where are these things going to land in the right places. New regulatory regime, which has generally been an enabler. That's the modified Part 23, which I think kind of opened up the whole story about 5 years ago with what are called performance-based standards and consensus-based standards for certification. And then the two biggest ones that are, I think, are in some way the most challenging is new airspace design to enable a crowded urban airspace. A lot of great work that's been going on that for a long time, but the last new airspace design was a sort of 30-year process to get it put together. And related to that, new air traffic control systems and how are we actually going to stand those systems up and really make them go. There's a more detailed conversation to have, and I'm sure the players who are working on UAM are thinking hard about how they can work within today's framework for each of these, right? And my goal is not to bash that vision. I'm not as engaged with it as I am with the regional vision. And there's a lot of smart people there, and there's a lot of capital that's been invested. So they're going to do something cool. And I don't know exactly what it is. But for my own purposes, I've found the case for RAM to be nearer term, more concrete, and more compelling.
Right. Thanks. So one thing you mentioned, we want to explore the 3D space, but at some point, the 3D system had to interface with the 2D system that we urban system have, right? So it seems in the RAM case, we can very much utilize the 5,000 grossly underutilized airport as the foundation, right? So beyond that, do you think any additional important infrastructure need to be constructed before the RAM vision can be realized, purely from the infrastructure point of view?
Well, as I mentioned, charging infrastructure at airports is one thing that needs to be addressed. And I don't know, well, I do think it's simpler than the charging infrastructure problem with automobiles. That's probably the biggest one. Although then there's all the maintenance and support infrastructure, right? And much of these, what's called a Part 135 certificate, which is the FAA approval to operate as a charter operator. I mean, probably a great deal of that is as much about the organization and its practices and how it works. And, we spent 100 years getting the aviation system we have today to the level of safety that it's at. And it is a remarkable level of safety. We don't really know how to think about the interplay between autonomy and safety for what's coming. And it will take time to build that up. At the same time, there are ways within the existing system to start and get moving, and then let the new technologies come as they may. As I mentioned, the Cirrusjet, you can buy emergency auto land on that aircraft now. It's a regulatory problem to enable a Part 135 operator to get credit for that emergency auto land and use it to reduce costs and enable new operations in a new way.
Great. Thanks, David. So I saw a lot of very good questions here. I may pass to Annie sooner today so that we can entertain more audience question here. Maybe I'll ask the last one, where in the second half, David, you mentioned that beyond the regional air mobility to a broader societal question, both the industry development, but also its connection to the future of work, the future of labor, etc. I just want to get your general comment on two things, right? One is what does regional air mobility need in terms of the talent and the labor pool? How much kind of a shock or opportunity can bring from the labor perspective, right? The second one, I do also want to listen to your about the international context, the competition of the technology, the competition of the talent. In terms of the regional air mobility, what do you see as the advantage that the United States has vis-a-vis Europe or Asia or other like a lot of players are in this international context? What do you observe with this?
Yeah. So to take the first question, again, I sort of going through this talk, I made the assumption that mobility is a good thing, right? And I think in the mobility forum, we can probably make that assumption. And people will take advantage of it when they have access to it in an affordable way. And but I also want to be clear, and people flows are also capital flows, right? One of the reasons it's difficult to start a company and finance it outside of a big innovation cluster is it's hard for both entrepreneurs and investors and engineers and workers to get back and forth, right? And so when you improve people flows, that's not the whole story, but that's part of the story. Again, I find Beta up at the Burlington, Vermont airport just a wonderful, remarkable story to see that level of innovation up there. But I know Kyle Clark, the founder, and he has some challenges in hiring in that environment, which I find a little amazing. I mean, I believe him, but people want to work in new ways, and remote work and 2 days in the office, or I often think about, is it 4 days a month rather than 2 days a week? You go to the city, you go to your company, you have 4 immersive days of 3 meals a day with your coworkers and do all the team building and conversational type work, and then you can go back to your home wherever it is a few hundred miles away. Maybe that's as viable as a 2 day per week kind of model. I think toward the second question, well, first of all, the U.S. has a huge competitive advantage, as I mentioned and Kevin mentioned, with just the sheer number of airports is unheard of, and also the kind of freedom to move within that system. Many countries, the airspace is really primarily owned by the military. Most countries don't have as well-developed general aviation systems as the United States does, and that's actually. I don't know that it's a competitive advantage today, but I think regional air mobility is partly about leveraging that infrastructure to make it into a competitive advantage. At the same time, you do see, and you are starting to see, both the UAM companies and the REM companies going to New Zealand, going to Japan, going to other places to do testing because they're finding it difficult to do it in the United States because of the nature of the regulatory regime. That's something I think we want to be really careful about.
Great, thanks. Now I pass to Annie to summarize the audience question for David, please.
Thanks, Junwan. David, you made my life very difficult here. Our best presentations generate the most questions. So there's a lot to curate and to get to here.
And I haven't been able to follow any of my chats. So.
I'll apologize in advance to the audience. We might not get to all of them, but I'll do my best to do so. So the first big question that's come up a couple of times from Byung-Jun Kim and Ravi Mishalani here is high-speed rail versus regional air mobility. Could you speak a little bit to the cost-benefit calculations between the two, that being kind of the other big regional concept that's discussed a lot?
Well, yeah, that's actually a really important question. And I think high-speed rail is always going to be more efficient, more effective, and more cost-effective in the places that it gets laid out. And so arguably, when there's an investment, a level of investment for high-speed rail, most people think it actually competes more with traditional airlines than with regional air mobility. If you can take a high-speed rail train, that's probably always going to be the best option, but it's very route focused. And RAM is a node-focused system, not a path-focused system. And so, you would want to imagine, and again, in the United States, at least, high-speed rail, there are projects afoot to extend it, but it's going to be limited in its own ways. And so, I think from energy and I think just basic economics point of view, where it's available, it'll do better than aviation always. It's hard to beat trains for a whole bunch of those density and efficiency factors. But it's always going to be confined to the routes that it's designed for.
That makes a lot of sense. Then we also have a series of questions. I'm going to call them almost cost and business model questions of Devin Wilkins asks, as a transportation mode, will the cost of RAM ever be accessible outside of the luxury market? So that's the most direct version of that question. But Lucy kind of spins that in the equity element of saying what would have to happen for this technology to actually improve equity and access and be more affordable? And maybe what does the business model look like? The one that's most realistic and the one that could actually make this more accessible to kind of other groups of people beyond the luxury market.
You know, so there are business models out there that envision, you know, for the kind of 200 to 500 mile segment, costs coming down. Of course, it's the magic, you know, chicken and egg of scale and cost that companies and capital have to solve, where the costs come down to, you know, comparable to auto travel. And actually, the energy usage models also say you can do it for about what the electric power of a Tesla would be over those ranges. And obviously that's key to making the system accessible and equitable. At the same time, I think one of the interesting questions, which I've only really mused upon, I haven't really thought too deeply about, is you know, look at the labor markets today, and particularly the labor markets for technical talent. That's obviously the one we're all most familiar with. And, you know, would I, as a company, pay a few $100s a week to enable a technical employee to travel, you know, across a region to be able to work? You know, what's that value? And what is the value of the, you know, reduced living costs and other pieces there? And I think there's some really interesting questions around modeling overall, you know, even for individuals, but also for employers, real estate costs, costs of living, salary, along with mobility, and seeing how those numbers really play out.
That makes a lot of sense. And there is a question too of who will dominate this market. Do you think it will be kind of the traditional airline companies? Will it be these, you mentioned a lot of smaller, newer companies in the space? Who do you think will dominate both, I guess, the technology itself, but then also the business model as far as the flows?
Well, one of the things that's interesting in both the UAM and the RAM is that a lot of the companies, at least at the moment, are saying they're going to both be the operators and the manufacturers, right? So you don't fly on Boeing Airlines, right? Boeing makes airplanes, and then other folks, United and American and other airlines, operate them, right? And you don't drive in a car that Uber manufactured, right? You get in an Uber that's operated by an Uber driver. Currently, a lot of the startups are saying they want to both manufacture and operate. Not all of them are saying that, but some of them are saying that. That'll be interesting to see how that plays out. The airlines, you know, are a little bit involved. In United, particularly, has placed an order with Heart Aerospace last year for a few hundred aircraft. They've sort of abandoned this market already, you know, hard to say if they'll get aggressive in going in there. Again, I tend to think of them like, you know, they're 20th century mass production companies. They're really good at making, you know, giving you any trip you want as long as you're going from New York to Chicago. And organizationally, it doesn't feel like they're the ones to really move quickly enough. And again, just to go back to Clay Christensen's original ideas around disruptive technology, you'll notice I haven't used that word, and I think it's overused. But part of that story in his original idea is the new stuff doesn't really work that well when it's new. And that's why the big players ignore it. And by the time it starts to work well, it's too late for the big players to ignore it. That may well be true here. These, the market sizes, the uncertainties are probably not attractive to the airlines, which are struggling to begin with and are very low margin businesses already. That's not to say they wouldn't buy up some of these players if they succeed, but Cape Air has been independent for decades and they just keep doing their thing.
Yep. So for the next round, I'm going to do a speed round of 4 potential problems that could arise that have kind of emerged in all the questions. One, Claude and Riley pointed out birds, what additional problems this might present for bird populations that are already very much affected by existing flights. One is weather. If weather, Naoki Kobayashi was wondering if weather affects this form of air mobility at all. 5G has come up. Sorry to be throwing these at you in such rapid fashion, and noise. So birds, weather, 5G, and noise would be the main question as to how that would be different for this as opposed to traditional air travel or alternative modes.
Okay, just to go backwards, the RAM aircraft we're talking about, well, again, electrical aircraft are going to be lower noise than fossil fuel aircraft just by the nature of the power generation. And they're just also generally smaller. And and again, one of the credits to Kevin and his team is that community compatible was a big part of their vision for RAM in the NASA report, and there's a lot more detail about that. 5G is a funny one in some way because the huge blow up over 5G and radar altimeters last month, was a very curious thing to me as someone who works in RF and spectrum and has faced a little bit of that also. Strikes me as an eminently solvable problem, even where there is 5G interference, although there's not good data on it. If I was flying in an aircraft that was that reliant on its radar altimeter, it would already be a scary thing because RF is always a little sketchy that way. So other sensors, various forms of redundancy, we're all, John Leonard is here, we all know about how to engineer systems that are mixed for different types of sensors and accommodate for sensors suffering interference. Some airliners today may not be suitable for that. That's the issue, is that kind of re-equipping cost that 5G faces. Weather is always an issue in aviation. It's very precisely measured down to, what is a day you can land with 100-foot ceilings of clouds versus 50-foot, versus some aircraft can even land 0-0. And each of those things costs money, and each of those things is somewhat mitigated by technology. Most of the startups that I mentioned are working on flying in good weather parts of the country. A place like the Northeast is more challenging that way, although I think ultimately these aircraft have to do that. No airplane can fly in all weather. And then there's a sort of, how much do you want to spend to be able to fly in certain kinds of good and bad weather? I actually tend to believe that a little bit of schedule flexibility buys you an awful lot there. So like when I fly myself, I cancel flights all the time, but I do it sitting on my couch at home. And I know when they're being canceled, and it's not nearly as painful as when you get to the airport and they cancel your flight and you have to wait there in somebody else's waiting room for 12 hours. And there's actually real opportunities to reduce costs where people can get used to traveling a little bit more in harmony with the weather rather than harmony with the clock. And that's something that we've grown used to. It's important in certain situations, but in many situations, it's not that important. If people rethink the way they do that, and they probably ought to do that in their cars as well. Birds, I'm a lot less familiar with, although I think, again, smaller aircraft generally are going to have a lesser impact, and especially on the noise side.
Thank you very much, Jim. I'll turn it back over to you.
Sure, yeah. Thank you so much, David. And this is really a fantastic presentation and a lot of good, interesting conversation here. So please join me, thank Professor David Mindell again.